everybody. All right, so we're doing college algebra here. We're looking at a review of a test question, possibly, potential hint. So, since we do have a problem with these, I noticed a lot of students have trouble with this. Let's go ahead and just do one for the sake of reviewing one, and we'll be okay with it. So we have degree 3 polynomial with integer coefficients, and zeros are 2i and 7/5. Okay, so working this thing back, I would have had an x equals 2i and an x equals 7/5, right? That would have been a consequence of getting the factors together, right? That would have been a consequence of something like this. Okay. Now, before I get to this one, I'm not gonna write it this way. I'm gonna do it a slightly more a longer way. But I want to get this to look at something this way instead. So multiply by 5, that cancels. So we have 5x is equal to 7, and then put the 7 over, so we get 5x minus 7 equals 0. Okay, here we would have had x minus 2i equals 0. Okay. Now with this one, because we have a complex number here, complex numbers automatically, their conjugates are automatically a 0 as well. So if one complex number happens to be a 0, then its conjugate automatically comes out to be a 0. So we also have x plus 2i. X equals negative 2i would have also been a 0, and it's just kind of implicitly there. So the coefficients I have here, x plus 2i, x minus 2i, and then 5x minus 7. Right. Go ahead and deal with the conjugate part first, because I don't want to make a mess with it. And because it's a conjugate, stuff is going to cancel. So we have x squared, we have plus 2i, we have a minus 2ix, and then we have a minus 4i. It's just foiling all of it. X squared, we have plus 2 minus 2, so that's 0. And then I squared is really negative 1. So that's x squared, and then 5x minus 7. Now, one of the things that they will have us do is just multiply all of them. And if you were taking intermediate algebra proper, they have a whole chapter. Okay. You just multiply them out. Like, okay. So I'm kind of glad that they make us do this. It gives us some practice. But this is going to be minus 7x squared. So here's 7x squared plus 20x minus. So we'll write in here. This was 5. Minus 7. This was what? Plus 6. And I think it was minus 28. Minus. Oh, it doesn't grade it for me on this one. It just says okay, and then you can figure it out at the end there. Okay, but that's how you do that. Okay. Oh, you know what I'm going to ask you to do is to mute yourself, because I'm getting feedback from you. Thank you. All right. So that's what you do with those. And again, if this is running you a problem, I completely understand, because I know that students have historically had a difficult time with that. So I'm not gonna, if you're doing that, and this is a hard thing for you, you are not alone. Okay, but that's how you practice those. So let me go ahead. We're going to talk about a new number today. Well, we're going to talk about part of a new number anyway. Before we got cut off yesterday, we were talking about compound interest. Right? And when you open a savings account, like if you buy a CD or something, or certificate of deposit, these are like long. Well, I shouldn't say long term. These are like short term loans that you're giving to the bank. You're giving the bank permission to use. They're slightly higher interest rate than a savings account, and they usually go for 3 months, 6 months, a year. Some banks have 2 years. I don't know how common that one is. 5 year, and I think there's some 10-year and some 20-year ones. But mostly people use them in this range here. Okay, maybe this one. But like I said, they offer slightly higher interest rates. Right now, interest rates are in the embarrassing level, and so you're just slightly above embarrassing. Okay, which means not really worth it. However, if you are the kind of person that would say want to save a certain amount, like they tell you, like you should have 3 months of income or 6 months of income saved up in case you get laid off. The way to start that is to do like maybe you buy a CD every other month. Put like $500. There's a minimum. There's always a minimum. Some banks have higher minimums than others, but maybe you put $500, maybe put $100 into a 3-month CD 4 times a year, and then every 3 months you just like, I'd like to add a little bit to this, and your bank will be able to walk you through their particular process for doing that. And between the interest and adding a little bit to it, then you'll have a year, every 3 months worth of something, all right, that you typically can't touch. If you try to withdraw this, they'll penalize you. So make sure it is money you can definitely live without before you dump it into this thing. Okay. Some people, they want to hear, take your how much you want to save and break it up, how much are your monthly bills, and dump that amount into a CD, or dump part of it into a CD and build it up over time. But every month and the first of the month, just go buy another, go put some money into a CD, whatever the minimum is, if you can. And then when it comes due, you can just tell the bank, like, hey, I'd like to add $5 to this. I don't know if they're going to do that, but like credit unions are more forgiving of doing this than banks are. But if when you get $100, I'm like, okay, I can live without this for a while. Put that in there. I'll save it for in case I get laid off. And then it's called a ladder. You can do that. But they compound like every month, or usually every month. They compound every month. And the formula we use for that, and this is the real formula, okay? We're not lying to you. We're not making it easier. This is the formula that we use, okay? So this is the amount that it's worth. This is the principal. So this is the amount that you put in, okay? 1 is 1. R is the APR, okay, expressed as a decimal. All right, so, in far off lands and far times ago, like you might see an APR, annual percentage rate. Of 3%. Yeah, that's considered really high today. Okay, you have to convert this and write in 0.03. If you tell me that R is equal to 3%, you are effectively telling me that you are working for a title loan company and you would really like people to sell themselves into slavery for you. Okay, because those title loan places, those payday loan places, their APRs are like 500%. So your R for them is going to be 5. Okay. So I tell you this because this is the most common mistake that students have, and I don't know how much experience people have with putting money in a savings account, but it doesn't grow all that quickly. Okay, so N is number of compounding periods, number of compounding periods. Okay, so per year. All right, so if we were compounding once a month, n is 12, right? If you were going to compound like twice a month or every 2 weeks or so, right? Then if it's by your paycheck, right, and it's 24, this is paycheck schedule. If it's every 2 weeks, right, that's going to be or every other week, that's going to be 26 for every other week. Daily, I'm so glad that we live in the 21st century for some things. So when I went to high school, you had to know, like, well, is it daily international or is it daily United States? Is it daily banker? Because these all had different values, and we had to memorize all of that stuff. Now it's 365. That's it. We don't count holidays. We don't do anything with that. We don't skip any days. Because some places are like, it's 360. It's this. It's that. Like, oh, come on, really? It's 365 now. That's what daily means. 365. It could be twice a year, right? It's semi-annual, so it could be 2 for twice a year. Quarterly for 4. Okay, 4 quarters to a year. So just depending on like how they compound it, that's what your n is going to be, and they will tell you in the problem. Most common is monthly. Okay, that's the one. If you want to practice, n is 12. Okay. Rate, right, that's the 3% expressed as a decimal. And then T, well, this is annual percentage rate. So T is in years. It's very common for problems like this to say you hold the investment for 18 months. Like, okay, that's 12 plus 6, right? That's 1.5 years. So don't let them fool you with 18 as a time. Remember, it has to go back into years. Okay, 6 months would be half. So let's just try one for the sake and see how the arithmetic works out here. All right, so say we invest $500, okay, into a CD. We really like CDs for this because usually people do not make early withdrawals, so you don't have to do any kind of like minus this halfway through or anything. It's just done. Okay, we invest $500 into a CD for 1 year. The CD earns, let's live dangerously, 2% interest. You think I'm kidding, but I'm really not. I mean, you can get 2% interest, but like you have to have like a $50,000 CD for that to happen. That's not gonna. I'm not gonna see that. But earns 2% interest and is compounded monthly. That's what CDs live like, and for 1 year. Okay, how much will the investment? How much money will you have at the end of the year? Of the investment. One year. Okay. So let's go ahead and do this. This is A is equal to P1 plus R over N raised to the NT. I'm inclined to write this formula down for you. I don't think you should be memorizing this one. So unless you're an accounting major, don't bother memorizing it. You could always look it up. Maybe you'll do enough problems that you won't need to memorize it. You'll just know it from now on. Okay, but we want to know how much money we're going to have. How much money did we put in? That was 500. 1 plus. What's our interest rate? 2%. Oh joy. How many months are in a year? 12. And try to know things like, I mean, I remember teaching one class where they, NT, here, this should be N. 12 times 1. I remember asking them, like, they had this thing where they had to figure it out by weekly. And they do a year later, and it's, well, there's 12 months to a year, and there's 4 weeks to a month, so there's 48 weeks to a year. How long have you lived on this planet? Okay. So there we go. I did not say that to them. I mean, there's all, that's what I thought that. I was like, there's, maybe you haven't worked for a paycheck yet. There's 52 weeks in a year. Okay. 500, 1 plus 0.02 divided by 12. That's also why if you know all of this stuff already, then it's going to be a little boring for you to talk about CDs. But I also noticed that students generally don't have a good handle on this. Okay, 500 plus, or 500 times 1 plus 0.02 divided by 12, parenthesis, or a caret, right, to raise to. And if you've got anything more complicated than like 12, put the parentheses in. I know a lot of students, they like to put the whole thing in. Like, okay, that's cool. Just put the parentheses in to make sure it's going to calculate it correctly. Because if you do, it's 2 years, it'll be, say, to the 12, and then multiply the whole thing by 2. And that's not what you want. You want raise 2. All right. So at the end of our year, A will be $510, 0.09. All right. Hooray. I say, if I just did simple interest, I would have got $510. I'm like, yeah, I know, but now you get an extra 9 cents. So, it's good. The way you're really going to make money is if your time expands to a lot, okay, which good luck, because humans don't live that long, and making this rate go higher. Okay, the number of compounding periods, like the change between quarterly, weekly, all of that isn't going to change this very much. Okay, when you're looking to, like, how do you make real money out of this, that's got to change. Okay, that's your factor. Notice that I was not surprised by $510.09. There's a lot of time. Let me show you what happens if we work for Misery Inc. car title insurance here. All right, and if I forget to do that, what happens? Okay, so this is the wrong way. Okay, the only people that are happy about this are the people that own the title loan policies. Okay, times. Sorry, I have a little bit of a bias against it. If you work for one of those places, this is not about you. Okay, I know that you're a pawn. If you own one of those places, then we can have a different discussion about the fact you're a terrible human being. Okay, so notice that when I forget the decimal place, we come up with an amount that is huge. Okay, here's your word for the day. Usury. This is when people charge way too much interest. This used to be a crime. When you talk to people about loan sharking, this was the crime that they were accused of. It's called usury. It's charging too high of an interest rate. I hope I spelled it right. Now, this is not a crime anymore. I think the highest interest rate you're legally allowed to do is like 29.99%. But, again, payday loan place, 500%. They just call them fees rather than interest. So that's how they get around it. Okay. So speaking of being usurious, okay, what we're going to do is we're going to do a little experiment. And let's see. We're going to loan $1 million. Well, we're going to take out a loan. Okay. For $1 million for 1 year. Okay. At 100% interest rate. So a lot of ones in here. So if we compound it once a year, so I'm going to say, here's my n, it's 1. Okay. And I'm just going to remind us, A equals P1 plus R over N raised to the NT. Okay. So the amount that we're looking for here is going to be A equals 1 million. Okay. 1 plus, well, 100% interest rate is 1. Okay. And we're just going to do it for one time per year. And then we're going to raise it to the 1 power. Okay. So this is really great. This is 1 plus 1, right? 1 over 1 is 1. So 1 plus 1 is 2. So we have $1 million times 2 for 1 year. That is equal to $2 million. Okay. Sure, we're all able to pay that right off. Okay. What if we compound it 4 times a year? Let's see what changes. So we're going to get A is equal to 1 million. 1 plus 1 over 4, right? The 4 changed. Raised to the 4 times per year, and we're going to have to use a calculator for this, okay? So this is going to be 1 plus 1/4 raised to the 4th power, okay, times our 1 million. And just changing the number of compounding periods, right, to 4 rather than just 1. What is that? 2, 4, 4, 1, 406. Okay, we owe almost $500,000 more. Okay. What if we change it to 12? Right, it's compounded monthly now. A is equal to 1,000,000. 1 plus 1 over 12 raised to the 12th power. So we have 1 plus 1 over 12. Oops. Plus 1 over 12 equals. By the way, if you have me for pre-calculus, you're going to be sitting through exactly the same demonstration because we did this again. So this is 2, 6, 13, 0, 35. And the nice thing about money is that there's a natural place to round it, which is the cents. What if we do it daily? Okay, so going from quarterly to monthly, we only added another $200,000 to our debt. Okay, nothing. One plus 1 over 365. By the way, if you get a cash advance for your credit card, this is it's compounded daily. So this is 1 plus 1 over. You guys don't live next to Atlantic City, so it's not quite the experience or the opportunity to do this that I had when I was young. Okay, and then times a million. But if you go to Vegas, right there you go. You'll have a chance to. They love it when you take out money for cash advances off your credit cards. So 4. Oh, I messed up with the number of zeros. This is 5.67 and 48 cents. Okay. So again, we went from 2,600,000 to 2,700,000, even though we went from monthly to daily, right? That's like an order of magnitude change. How many hours are there in a year, right? That's 365 times 24. So that's 365 24. Okay, so there are 8,760 hours. Okay, and A is equal to 1 million. Oops. Times 1 plus 1 over 8,760. So again, we went from hundreds to thousands. We're going up by an order of magnitude. How much is this going to change? Okay, the answer will surprise you. So 1 over 8,760. Okay, raised to the, so it doesn't look like a big number, but we're going to raise it to the 8,760. Right? And then times 1 and then 6 zeros. 1, 2, 3, 4, 5, 6. Okay, and we get 2718126.69. All right. It didn't change by very much, did it? So the other ones changed by 100,000. I mean, that's a pretty big change. This one is now changing by $4,000. So in the course of a million, $4,000 really is not that much. Let's see, that was hours. So 8760 times 360, because it's 360 seconds to an hour. No, 3,600 seconds to an hour. So in a year, there's 3,153,600. Yeah. So that's 31 million. Okay, there we go. Okay. 31 million seconds in an hour. So if somebody comes by, see, after this, you could become, you could be an accountant for a loan shark. I'm sure that'll work out just fine for everybody. $536,000. And what does this equal? And how much do you think it's going to change? All right. You're saying, I don't think it's going to change by a whole lot. You'd be right. This is, you know what? I could just do this. Answer. That'll do it this one. And, I'm going to be more clever. Insert parentheses and parentheses raised to the answer. That way I don't have to type that number in. All right. And then times 1 million. You got 2718282. So we went up, right? We changed in the thousands. Now we're going to change in the hundreds. And I went from thousands, right? I went from almost 10,000. That's 1 times 10 to the third or fourth, to how many zeros we got? How many decimal places we got here? We have 3, 6, 7. 1 times 10 to the seventh order. So we went from 4 to 7 here. And we changed it in, right, 1 extra point. So if you think like, this looks like it might be kind of aiming at something, you'd be right. And what it is aiming to. So if we do this, if we say this number here, 1 plus 1 over n raised to the n, I'll say as n tends toward infinity, or grows without bound, okay? That's dead. All right. We get a certain value. This gets closer and closer and closer to a certain value, and that value is called E. Okay, this is for Euler's number. Okay, and E is approximately 2.71828, 5, and then it keeps going. E is kind of like pi. Okay, it just keeps going on and on and on. There's no kind of pattern to it. The only reason I know this to about 10 decimal places is when I learned about E, and now I'm going to saddle you with the same trivia, is that the inauguration date for Andrew Jackson happened to be 1828. Now, I learned this number in the 80s, so there wasn't like a thing about Andrew Jackson back then. For whatever reason, my math teacher was like just a real big fan of Andrew Jackson. I am not. I mean, people can look him up, but you know, when you learn about Trail of Tears, he's the guy who ordered it. So not a particularly good president, but that's the day he was inaugurated. Okay, so that's how come I remember this thing, and now you will too for the next 30 years. So enjoy that. But that's how I remember E. There's a couple other ways to get E. It's actually pretty, it pops up a lot. Okay, do you know what this symbol means? And this is, it's not an excited 5, it means factorial. And that's 5 times 4 times 3 times 2 times 1. Okay, if you take a lot of probability classes, you will learn what that value is memorized. Okay, because there's 52 decks, 52 cards in a deck, and we have to divide by this thing, right, to say like how many different ways are there to draw a card. Well, not quite, but this comes up pretty often in probability classes. But it's just going to be 52 times 51 times 50 times 49 times ... all the way down to 0 factorial. 0 factorial, I'm going to use 3 equal signs, is equal to 1. 0 factorial is defined to be 1. Okay. So in order to do this, in order to get E, we could say this is 1 over 0 factorial, which is just 1, plus 1 over 1 factorial, which is still just 1, plus 1 over 2 factorial, plus 1 over 3 factorial, plus 1 over 4 factorial, plus ... Okay, that's also E. When you go to do your homework, they're going to say, well, what's 4 times E? Okay, and the way you're going to get this on your calculator is you're going to say 4 times, and you use second function ln. Okay, so second function ln. And it's so common to use this as an exponential function that it automatically pops up with the exponent in there. So we just wanted e to the first power, because that would be e. So 4 times e, right, that's equal to 10.87, or however many decimal places they want you to go. Like I said, it's like pi. We can go a lot of decimal places before we run out. Okay. If they ask you, like, hey, what's e squared? Right. Second function, ln, to the 2 here, and then we've got this. Okay, 7.389, and it just keeps going. Okay, so that's how you use your calculator to get numeric values for E, kind of like you can use your calculator to get numeric values for pi. Okay, so that's the kind of number it is. It's irrational. We'll talk about that one tomorrow. But that's when you're looking at your homework for the first section, and they ask you what's 4 times E, or what's E to the 2, or E to the 3, or E to the 1.5, whatever. You can get this now. Okay, so you know this is amazing, right? This is, when's the last time you learned a new number, right? So now you know the number E. You also know the number I. So someday I'd love to see a Sesame Street where they bring you the, Sesame Street brought to you by the numbers E and I for a change, but I have a feeling that I'm going to be waiting a long time for that one. But that will let you do your homework for the first part of this thing, and we will continue with exponential functions next time, and we will use E. Well, not a whole lot at the start, but in calculus we really like E, because exponential functions with E don't have to have a scaling factor. Every other number, like 10 to the x, 1.03 to the x, any other number, you have to have some kind of a scaling factor. And I never remember if you have to multiply by it or divide by it. It's one or the other. So in calculus, we really like this number because there is no scaling factor to go along with it. Okay, so I'm going to go ahead and leave us with that. Okay, and we will pick up with doing this stuff tomorrow.